everyone. For this video lesson, we only have one focus, and that is to validate mathematical statements using indirect proof. There are mathematical statements that are difficult or even impossible to prove using direct proof. In such cases, we can resort to using indirect proof. To easily understand this, we can use this analogy. Suppose my neighbors accuse one of my cats, Aryo, of destroying their plants. Now Aryo has to defend himself, and this is how he does it. He says, suppose I did destroy their plants. Then I would have to be in their yard to destroy the plants. But I have been studying in my room since yesterday. If I destroy their plants, I would have been in two places at once, which is impossible. Therefore, I couldn't have destroyed their plants. He makes sense, doesn't he? He's so smart. So let's examine Ario's reasoning deeper. Ario's statements actually resemble the steps that we do when we use indirect proof to validate mathematical statements. Let's look at them one by one. Ario said, suppose I did destroy their plants. This is tantamount to agreeing to the neighbor's accusation at first, which is also the opposite of what he wants to prove, because what he actually wants to prove is the opposite, that he is innocent and that he did not destroy their plants. This is equivalent to the first step in making your indirect proof. If you are given a mathematical statement to prove, you have to first assume that the opposite of the statement is true. The second statement that Oreo made was, then I would have to be in their yard to destroy the plants. But I have been studying in my room since yesterday. Or that is, he proceeded to the logical proof of the accusation. And that is also equivalent to the second step in making your indirect proof. You just proceed to proving the opposite of the given mathematical statement. Thirdly, Oreo said, if I destroy their plants, I would have been in two places at once, which is impossible. So he came up with a contradiction to the statements that he made. And that is the third step of our indirect proof, which is to find a contradiction to the opposite of the mathematical statement that was given to us. And lastly, Oreo said, therefore, because there's a contradiction, I could not have destroyed their plants. And there's a contradiction to the opposite of the statement that he was trying to prove. So, because the opposite was false, therefore the original mathematical statement is proven to be true. So that's tantamount to our last step in our indirect proof. In here, we conclude that since the opposite of the statement is false because of the contradiction that we found, then the original statement, the one that we actually want to prove, is true. To further illustrate that point, let us have an example. Let's say we want to prove that square root of 2 is irrational. So we begin with the proof by stating the statement first. The statement is the square root of 2 is irrational. So the negation of that is the square root of 2 is not irrational, which is also equivalent to saying that the square root of 2 is rational. Now, because we said that square root of 2 is rational, then we should be able to express it as a fraction of integers a and b. That is, the square root of 2 is equal to a over b. This fraction is fully reduced, so a and b are relatively prime, or they have no common factors except 1. Now, since we said that the square root of 2 is equal to a over b, then if we square both sides, we get 2 is equal to a squared over b squared, or that is 2b squared is equal to a squared. Now, since a squared is equal to 2b squared, then a squared must be even. Hence, a is also even. Since a is now even, then b must be odd so that they won't have common factors. If b is also even, then that would become even over even, so there would be a common factor, which is 2. Moreover, since a is even, Then there is an integer c for which a is equal to 2c. What does that imply? Since 2b squared is equal to a squared, and we actually said that a is equal to 2c, then plugging 2c into a squared, we get 2b squared is equal to the quantity of 2c squared. Now solving for b squared, from 2b squared is equal to the quantity of 2c squared, we have 2b squared equals 4c squared. And of course, we could solve for b squared by dividing both sides by 2, and we get b squared is equal to 2c squared. Now look at the form of b squared. It's equal to 2c squared, or 2 times the number. That would mean that b squared is also even. And since b squared is even, its square root b is also even. What does that imply? We earlier established that the square root of 2 is equal to a over b, where a and b have no common factors other than 1. But now we have proven that both a and b are even. Thus, we have a common factor, which is 2, and therefore we have a contradiction. And because we have a contradiction, our assumption that square root of 2 is rational is false. And since the opposite is false, then our given statement, square root of 2, is indeed irrational, and that is true. Now it's your time to try it on your own. Please try proving that the square root of 3 is irrational using the indirect proof. You can also find other examples in your student learning guide.